Welcome! Today we're going to pull back the curtain on something that feels like pure magic in your databases. I mean, how do they find one specific thing in a billion records, like instantly? Well, it all starts with a problem that I'm sure you felt before.
All right, let's get right into it. So I'm working with these massive data sets, right? Millions of records. And sometimes just finding one thing takes forever. If all my data is just thrown in there with no order, what is actually going on that makes it grind to a halt?
You know, it's kind of like looking for a single book on a bookshelf that's a total disaster. There's no system, no alphabetizing, nothing. Your only option? You gotta start at one end and just pull out every single book until you find the one you're looking for. Super simple, right? But oh my gosh, it is painfully slow.
So in the world of computer science, this whole brute force approach actually has a name. It's called a linear search. And really, the name tells you everything you need to know. You're just going in a straight line, one item after the next.
And a computer follows these steps to the letter. No shortcuts. It starts right at the beginning and just chugs along. Is this it? Nope. Is this it? Nope. Over and over. It's got no clue, no intelligence about where that item might be hiding.
So, here's the kicker. In the absolute worst-case scenario, let's say the thing you're looking for is the very last item, or maybe it's not even in the list at all. You have to look at every single one of the n items. We use this notation, O of n, to describe that performance. All it really means is that the time it takes grows directly with the number of items. Double the items, you double the search time. Simple as that.
Okay, that totally clicks. So that's why my queries are timing out. I'm literally asking the database to check millions of things one by one. There has to be a better way, right? A smarter way? So, what's the secret?
And that right there gets to the absolute core of it. The secret isn't some super complex, fancy new search algorithm. It's much simpler. It's better organization. The moment you sort the data first, you unlock a completely different and dramatically faster way of finding things. It's a total game changer. And that new strategy has a name too. It's called binary search. Now, instead of going one by one, it works by dividing and conquering the problem. It's just incredibly efficient, and it works because the data is already in order.
Just think about looking for a name in a phone book. You know, one of those ancient paper things? You don't start at the A's and flip every page. No way. You crack it open somewhere in the middle. You see her in the M's. And if you're looking for Smith, you instantly know you can ignore the entire first half of the book. Boom. With one move, you've thrown out half the data. You just keep doing that.
So this divide and conquer magic gives us a performance we call O of log n. Now, I know O of n and O of log n might sound kind of similar, just a few letters different. But trust me, the difference in how they perform in the real world isn't just big, it's absolutely staggering. Let's actually look at the numbers.
Okay, so O of n versus O of log n. Let's really break it down. What does this difference actually mean in practice, especially when we start dealing with a lot of data?
Okay, here they are, side by side. And you can see the trade-off right away. For linear search, your data can be a mess. For binary search, it has to be sorted. That's the one requirement. But the payoff you get for doing that sorting work up front, well, it's enormous.
And this is where it gets kind of mind-blowing. Look at this. For about 1,000 records, binary search takes 10 steps instead of 1,000. Okay, cool. But what about 1,000,000 records? Linear search could take 1,000,000 steps. Binary search, at most 20. 20 steps. And for 1,000,000,000 records, you're looking at potentially 1,000,000,000 steps versus around 30. That's not just a little faster. That is a fundamentally different universe of efficiency.
Wow. Okay, I totally get it now. Sorting isn't just a nice to have, it's the key to everything. But how does this actually apply to my database? Because I'm definitely not hitting a sort table button before I run every query.
Exactly. And you don't have to. The database is smart enough to handle all that heavy lifting for you, and it does it using a special tool called an index. To really understand what an index is doing, we just need to nail down two last little concepts.
First up is the sort key. This sounds technical, but it's super simple. It's just the column you're using to put things in order. If you sort a spreadsheet by last name, then last name is your sort key. That's it.
And second, we have satellite data. That's just a fancy term for all the other information in the row that's attached to the sort key. So in our spreadsheet, if last name is the key, then the student's ID, their email, their major,
All of that is the satellite data. It just comes along for the ride.
Okay, and here's where it all comes together. A database index is basically a pre-sorted copy of one of your columns, the sort key. So when you ask the database to find something using that column, it doesn't do a slow, painful linear search on your giant table. Nope. It does a lightning-fast binary search on that small, perfectly ordered index. That index points it exactly to where the full row, the satellite data, lives, instantly.
So really, an index isn't magic. It's just a really clever trade-off. You pay a small price to keep that index sorted, and in return, you get to transform a slow O of n search problem into a blazingly fast O of log n problem. That is the real secret behind why your database queries are so fast. And that brings us to one last really important thought. We've seen how amazing indexes are for speeding up our reads, but think about this. What happens when you write new data? Every time you add a new record or update an existing one, that perfectly sorted index has to be updated too. And that takes time. There's a cost. And that's the constant balancing act of database performance tuning.
Hey, if this helped you understand your tools a little better, we'd really appreciate it if you'd share this explainer and, of course, subscribe for more.